Hi, today I'll explain a brief math tutorial on quantum measurement. First of all, let's zoom in on a quantum measurement device. The quantum measurement device is equipped with a set of measurement operators. Each measurement operator is self-adjoint or called Hermitian. What is a Hermitian? If an operator is Hermitian, the operator is equal to its conjugate transpose. This star sign is a conjugate transpose. What is the conjugate transpose? Let's consider we have the following operator A, then the complex conjugate of A is changing the sign on the imaginary part of each entry from plus to minus and minus to plus. Then consider each column of the A bar. Then the transpose of the operator is shifting column to row. So we have the following conjugate transposed operator A bar T. Simply we call A bar T is A star. You may notice that A is equal to A star. So if an operator is a Hermitian, the operator is equal to its conjugate transpose. Because the measurement operator is Hermitian, we have the following properties. First of all, the conjugate transpose of the operator times its original operator is equal to the original operator. Secondly, the sum of all measurement operator is an identity. So the set of measurement operators should satisfy this completeness relation. As we know, the quantum measurement device produces a measurement outcome probabilistically. Then how can it compute the probability of measurement outcome P of M? The P of M is a projection of measurement operator on the quantum state times its conjugate transpose. Also, we should know that sum of all probability of measurement outcomes is 1. Quantum measurement causes a change of the states. After the measurement, the given state collapses to a post-measurement state. How can it compute the post-measurement state? We can compute the post-measurement state as follows. It is equal to projection measurement operator on the quantum state over square root of the probability measurement outcome. So we can compute the probability of the measurement outcome and the post-measurement state. What I have explained so far is a brief math tutorial on quantum measurement. Thank you for watching. God bless you.